We know that friction is always at work in the real world when we're trying to move an object. We have two kinds of friction that we talk about in our lessons. One is static friction. That's the friction that resists an object getting started moving. And then we have kinetic friction. That's the friction that occurs when an object is moving. So the first problem we're going to look at involving friction and forces is one in which we have a 35 kilogram crate that's initially at rest, and it requires 75 newtons of horizontal force to set it in motion. What's the coefficient of static friction between it and the floor? Let's start out by drawing a free body diagram. Now remember, a free body diagram is one where we can see what's going on with the object and all the various forces. So let's start out very simple here. We're going to write down that it's 35 kilograms. All right, and we know that a horizontal force of 75 newtons is required to get this object in motion. Now, our coefficient of static friction is equal to the force required to get that object to move initially, the maximum force of the static friction, overcome that to get it to move. And then that is all divided by the normal force. Well, what's the normal force? The normal force is the force that the surface on which the object is sitting on is exerting in the upward direction, opposite the gravity that is working in the downward direction. And this is the force of weight. So we're assuming that this object is sitting on a horizontal surface. Things would change if it were at an angle. So how are we going to calculate these forces in these opposite directions? When you do these, begin with finding the force of weight. We know that force of weight is equal to mass times acceleration. All forces are equal to mass times acceleration. But what acceleration is going on here? Well, this object is being pulled down by the force of gravity, and so we can use little g, 9.81 meters per second, if it's on Earth. Second squared, sorry. If it's on Earth. And so that's how we can find the weight. So we are going to do mg to find the force of gravity. So that is going to be 35 times 9.81. Get out trusty calculator. $35 times 9.81. 343.35. Let's just call that 343. What would our units be? Newtons, because it's a force. So this is 343 newtons. Now, because this is on a horizontal surface and our force is being applied horizontally, the normal force is going to be 343 newtons as well. You know, this block isn't floating up in the air and isn't falling downward. Therefore, those two forces must be at equilibrium. And so we know then that our normal force is 343 newtons in the upward direction. So now we can find this coefficient, that little u thing is a mu, it's our coefficient of friction. And that's going to be our 75 newtons, which is that force that's required to get it moving, divided by 343 newtons. So we've got 75 divided by 343, and we get 2 point, oh goodness, all those decimals, 0.22. Let's just call that 0.22. 0.22. Now there are no units for the coefficients of friction. Notice that those units are going to cancel out when we divide. So this is our coefficient of static friction.